Now let us discuss the different scheduling algorithms. First we'll see your first come first serve scheduling algorithm. So as the name suggests, whichever process comes first, the arrival time of whichever process is before, that will be processed first. Okay. Assume that process come in order P1, P2 and P3. P1 process comes first, followed by P2 and then followed by P3. Since P1 is the first process to enter, first P1 only will be executed. Okay. But as you can see, the burst time of P1. Burst time means the maximum time your process P1 will utilize the CPU. Okay. So your burst time is more for P1 and the burst time for P2 and P3 is less. But still since P1 has entered first, it will be fully executed, okay, and then only your P2 and P3 will come. So the waiting time for the other processes will be more in this algorithm. So next is shortest job first algorithm. So as the name suggests, we'll look for the process with the shortest burst time and that will be given the priority accordingly. Okay. And in this shortest job first, you can go into and in this shortest job first itself, there are two types. It can be either non-preemptive or preemptive. Okay, non-preemptive, we have no issue. Whichever has the shortest burst time will get the access to the CPU first. But for preemptive, we have to check for each and every time slot. Okay, and all the scheduling algorithm will solve using your Gantt chart only. So using for each and every time slot, we will be checking the burst time again and again when it comes for your preemptive, and whichever has the lowest burst time will be given the priority. Okay, so this algorithm gives a minimum waiting time. The next is your round robin. Okay, in round robin you have a quantum time. It means each process is given one particular time to complete. Okay, so in this example you have 10 millisecond. It means if process P1 enters, it can only execute up to 10 millisecond. Whether it is completed or not, the other process will enter again. Okay, and that also will be inside for 10 milliseconds. So this is your round robin. So all the process will get access to the CPU. Okay. Next is your priority scheduling. In priority scheduling, each process will be given priorities. Some will be a high priority processes. So whichever process has the highest priority will enter inside the CPU and the task will be executed. Okay, in this also there are two types. Your priority scheduling can be preemptive or non-preemptive. Okay. Next is multi-level queue scheduling, where the process can be divided into multi-levels. Okay, and according to that kind of process, your algorithms can be used. Okay, if you have multiple process, it will be grouped into a similar kind of process, and each group will be given and each different algorithms. Okay, so that is your multi-level queue scheduling. So as you can see in this diagram, the highest priority is given to the system process and the lowest priority is given to the student process. Okay, and according to that, the algorithms will also be given. The disadvantage of multi-level queue scheduling is that some process will never get the time to be executed. If you have more number of system process, obviously the system process is the highest priority, so that alone will be executed. Okay, the lower processes will not get a chance to get executed. So to overcome that disadvantage, we have multi-level feedback queue scheduling, where the process can go and fall in all the different level of queues. Okay, so as a so the all the process will move up the ladder. Okay, in this feedback system, all the process will move up the ladder and every process will get a chance. So that is one advantage of this multi-level feedback queue scheduling.